Welcome everyone, and thank you for attending today's webinar, Introduction to the Oceanscience Z-Boat 1800T, Survey Capability for Marine Construction and Dredging Projects. My name is Melissa Rossi, and I'm the Director of Marketing and Customer Service for Teledyne Marine Vehicles. And I'm going to give you a few housekeeping instructions before I introduce our speakers and we start today's presentation. So some just general housekeeping. In today's session, everyone is muted due to the large audience. So if you have a question about anything you see or hear during the presentation, please submit your question to us using the question button. You'll see that marked on your control panel, and I encourage you to do that as soon as you think of a question so that you don't forget it. You don't have to wait till the end. At the end of the presentation, we'll try to answer everyone's questions as they've been submitted. If for any reason you don't get or we don't get to your question, there will be a list of contacts on the final slide that you can reach out to for more information. I know I always get the question about, will today's presentation be recorded? So today's presentation will be recorded. And after about 24 hours, you should receive an email with a link to the recording from today's session. So first, before we go on, just a couple of upcoming events that we have with Teledyne Link, which is the webinar series that we are presenting on today. So on October 14th, we have the single beam Future is Here, Teledyne Odom's E20. Join Kim Daly, Sales Manager for Teledyne Odom Hydrographic, and Christian Shaw, Southeast General Manager for Telestra Technologies, as they journey into the single beam future with the Teledyne Odom Echotrac E20. They'll provide you with an in-depth look at this compact, reliable, and flexible system designed to take your surveys to the next level. Bear with me 1 second. For some reason, I'm paused here. There we go. Try again. There we go. So the next presentation that we have available is October 21st, which is Mapping the Great Pacific Garbage Patch. The Pacific Ocean is a hot spot for waste that we dump from our coastal cities or lose overboard from ships. Its currents push the trash into the middle of the ocean, where it remains for years, concentrating in a region called the Great Pacific Garbage Patch. Scientists and environmentalists are considering ways to reduce plastic waste, including Ocean Cleanup, who have come up with an idea of using static floating barriers that could capture the trash. Please join Jen Aiken from our sister company Teledyne Optech to understand how their bathymetric airborne LiDAR sensor helped Ocean Cleanup know where to deploy their barriers. And finally this month, we have an introduction to the new LBV2 on October 28th. You can join us as we introduce this latest vehicle offering from Seabotics on their VLBV2. The VLBV2 is our next generation light inspection class ROV, which is based on our highly successful Vectored Little Benthic Vehicle, or VLBV. The VLBV2 provides exciting new capabilities by taking advantage of hardware and software enhancements made to our core architecture over the past several years. Dan Shropshire will present that on the 28th, so we hope you'll join us. So now let's talk about today's presenters. So today we have Vitad Pradith. V is a product line manager for the Teledyne Marine Oceanscience Surface Vehicle and Seabotic Remotely Operated Vehicle, or ROV, product lines. His current focus is towards the advancement and development of unmanned technologies and solutions for the unmanned systems community. V also held roles in private-public industry related to the unmanned industry as a technical project lead and as a physical scientist at NOAA supporting the U.S. Nautical Charting Program. Jonathan White is our other presenter today. Jonathan is a Marine Construction System Product Manager at Trimble. Since 2001, he's focused on GNSS, LiDAR, dynamic positioning, and machine control technology, and their application of technology to marine environment and offshore nearshore construction projects. Jonathan has a breadth of experience in the application of software and hardware to provide precise heading and dredge tool position, enabling subsurface visibility and maximizing dredge productivity. So those are our presenters. I am now going to turn this over to our presenters to start the webinar. V, over to you.
Okay, good morning. Before I continue here, can I ask Melissa which screen that you're seeing right now? It didn't indicate on my computer here.
I see your presenter view.
Excellent. Thank you very much for confirming that. I appreciate that. Well, good morning, everyone. Again, this is Vitad Pradith, or please call me V. Thank you so much for actually joining. We know that your time is precious, considering the events that are happening currently right now. So I hope that everyone is fine and well here. And again, hello to everyone here too as well. Just a quick image on, just in case you're wondering who you're actually speaking with. So this is what we both actually look like here. I'm going to be in the background here, and Jonathan White, my colleague here, will actually start from the actual Trimble side here. And then I'll be seeing everyone in a bit here. But in the interim, welcome, and we look forward to having you. Jonathan, why don't you kick it off here?
V, one quick second. Hold on one second. I'm seeing your presenter's view, not the main slide, just so it's not so confusing okay. For each two slides.
Thank you. Thank you so much. I appreciate that. How about now?
Perfect. Perfect. You're all set.
Thank you, Melissa.
Sorry about that. Yep.
No worries. Thanks, V. Thanks, V, and thanks, Felissa. Good morning or good afternoon, depending on where you are in the world. My name is Jonathan White. I'm with Trimble. And as Melissa indicated, I'm a product manager for the Trimble Civil Construction Field Solutions division. And my focus is on specialty construction with marine in particular. And what we're here today to talk about is the Teledyne Z-Boat 1800T. That T at the end stands for the Trimble variant. Many of you guys, if you're already part of the Teledyne channel, you likely already know all about the Z-Boat. You might not know about some of the other components, particularly the Trimble components that V and I have packaged together as part of this offering that we're talking about today. But for those of you who aren't familiar with the Z-Boat, it is designed and manufactured by Teledyne Marine. It's a high-resolution, shallow water hydrographic unmanned survey vehicle, or USV, with a Teledyne Odom Echotrac E20, dual-frequency single-beam echo sounder, and a Trimble BX992 dual-antenna GNSS receiver with integrated INS. I thought I would spend a few moments before we dig into that a particular product offering and give you a little bit of the chronological history of the collaboration between these two companies. V, would you mind going to the next slide, please? There we go. So this started back in Q1 of 2017 when Trimble announced our intention to OEM software that's manufactured by Teledyne. Some of you may be familiar with the Teledyne PDS software. What we have done at Trimble is to OEM that software product and rebrand it with some of our specific feature requests and a few enhancements here and there. And we have rebranded it as Trimble Marine Construction Software, or TMC. So this does date back to Q1 of 2017. That's when this got kicked off. There was a lot of ongoing development and work throughout the rest of 2017. There were a number of licenses sold, so it was put into the field. But there were still some things that needed to be finalized, and the development was ongoing and is ongoing to this day. Next slide, please. Moving into 2018, after a lot of that testing was completed and we had some successful field installations in oceanology there in 2018, and some of you guys were likely present at that event that was in London. We released our official TMC dredge systems, and there were 3 of them that we launched at that event. One was for a marine excavator, a backhoe excavator. The second was for a wire crane, and the third was for a cutter suction dredge. And so these systems consisted of TMC or PDS software that we rebranded, and a number of components from GNSS for your positioning and your heading, and motion sensors to track the motion of the machine as it was moving. And of course, the whole objective is for all of that data and information with regards to machine location and motion to be sent back into the software so that you can visualize the machine as it's moving during that material removal or placement operation as part of a marine construction project. Next slide, please. This continued into 2019. There was a lot of activity in 2019. It was a very busy year for this partnership in terms of growth and expansion and market penetration. We held a number of training events worldwide in Europe, the United States, and also over in APAC, the APAC region. So it was very busy for us on the product management side of things, and for the sales and Marcoms guys as well. One of the highlights from 2019 was the introduction of the Teledyne T20 motion scan system. The T20 was already out there, but it didn't exist as the motion scan type of system. So when this was released, we now had the ability to integrate this into Trimble Marine construction projects using TMC software and the other machine guidance and control sensors and hardware components as well. So I realized that the image on the screen may not represent the actual pan and tilt system, but they're out there. This is just what I had available and what we had available today for the presentation. But a very exciting announcement and release from Teledyne, and exciting for our dealers and users. Next slide, please. So it brings us to 2020. It's been a strange year. I think we can all agree with that. But V and I started talking about this, oh geez, V, it was last year, and into the summer months. And I gave a couple of presentations at the Trimble Marine Technology Workshop in San Diego in October of last year. So that was kind of a preview. We did have BX992 on a Z-Boat there in San Diego at the event. It was still kind of a new thing though. We were still doing some testing, but we also brought this with us. V and Melissa were also present at Con Expo in Las Vegas there in March of this year. And we had a very outstanding turnout at Con Expo, and had a lot of momentum built, and we were very excited about what 2020 was going to look like. And then everyone knows what happened in March of this year. Things got a little bit weird, but nevertheless, we are moving forward with this product offering. If anything, it gave us a little bit more time to get better versed at the product offering capabilities, what we could and could not do, and to fine tune our marketing messaging. And we've already talked about this into the Trimble channel. Our distribution channel, and we're talking today with the Teledyne channel, and there will be instances, I believe, where those channels cross paths, or maybe even some of the people on the call are both. You may be a Trimble and a Teledyne dealer. If you're not, you can be. So those are things that you can talk about with the sales team at any time, and there will be contact information presented at the end of this webinar. Next slide, please. Okay, so this kind of gives a picture of, I believe, what Trimble is able to offer today as a result of this partnership. If you guys don't know much about Trimble, the company is actually very similar to Teledyne in many ways, in terms of size, revenues, internal structure, the product development, engineering. There are so many similarities. Sometimes it's surprising just talking to the team there at Teledyne, whether they're on the marketing side of things, sales, or engineering, product development. But the companies are very similar. What Trimble does very well is GNSS, machine guidance and machine control for civil engineering and construction projects. The bulk of our experience and all of our product development so far has been primarily on the land construction side of things. But what we have done over the last several years is take what we know about land construction and apply that to marine construction. There are, in fact, a number of concepts, workflows, and just overall procedures that are very similar, if not identical, to what you would do on land. Of course, the key difference is you are on the water, you can't see beneath the surface of the water. How are you going to do that? So we needed to partner with somebody who was an expert in underwater visualization. Teledyne leads the industry in subsea visualization, underwater visualization. So the partnership was born several years back in 2017, as I said. It made a heck of a lot of sense then. The collaboration continues to bear fruit and help us to augment and enhance our full suite of as-building solutions that we can offer to the marine construction industry. And what we're talking about today, the Z-Boat, gives us yet one other offering that can help us to continue to improve project proficiency and enhance safety by removing some of the manpower requirements, having the ability to use an unmanned survey vessel out there for your inspection or as-built surveying. There's a lot of value in having that ability, and it's not something that we had before. So the partnership with Teledyne has really helped us to round out our full suite of as-building solutions. And next slide, please. I think that I will turn it over to V for the next few moments to tell you a little bit more about the specifics of this Z-Boat 1800T offering today. Thank you.
Thanks, Jonathan. That was some great context there, and certainly, hopefully, for the customers here or the folks on this call, they sort of understand, the whole history here. And this is really not anything new. If anything, this is an evolution, sort of the actual partnership here. And I think, from my perspective, it's pretty exciting. Some of the stuff that we're working on as a team here. So we look forward to showing you that into the future. But for now, we'll focus on the 1800T here. Just real quick, just wanted to sort of give some context for some folks on this call who may not be familiar with actually Teledyne Marine. We're a subgroup under actually Teledyne corporately here. I specifically fall under that red triangle there, which is the actual which sort of covers our underwater side of things. So ROVs, unmanned surface vehicles, DTOs, AUVs, and gliders as well. Some of you know us as a conglomerate of about 23 different product lines. You may wonder how they're somewhat interconnected. They actually are in some way, in that they all are or all work underwater or in some sort of harsh area as well. We pride ourselves on our expertise in terms of the actual engineering team. So one of the primary ethos of the engineering team is basically there's a lot of tech that we have either in space or underwater. And some example of that is that we have, there's sensors that we have that are on the Mars Opportunity rover, up in the ISS space station as well, and that goes all the way up to space, all the way down, all the way to, deep down into the oil wells, right? So where it's cold, where it's harsh. So that engineering ethos, that philosophy, sort of actually permeates amongst all of the amongst the actual engineering team, but more importantly, down to the actual product lines as well. So I hope if you gain anything out of this presentation, folks understand that a lot of it's not one product that you're actually buying. It's the actual engineering design built into each actual product line, which sort of follows this common sort of expertise here. So the 1800T specifically that we're here to actually talk about, it's intended applications here. Again, I'm not saying that this is the end all be all. The ones that we are aware of, certainly as Jonathan had mentioned, is the marine construction sort of application. So anything related to dredging, civil construction, engineering, any sort of work that you might be doing in that area. So any sort of inspection or observation that might require people, right? So sometimes you have to hire a actual diver to go down and go check something. If there's a way to remotely inspect something without putting people in harm's way, this would be one potential tool that you could use, sort of that application. The mining the mining and tailing pond industry. This is one of the applications that certainly has seen an uptick in unmanned surface boat use. Just primarily, I think I have a slide on this in the pack here that sort of illustrates why these unmanned surface boats will work well in this sort of application as well. And a last application here is basically any sort of hydrographic surveying, right? So this boat specifically is configured with a high resolution single beam sonar, and Jonathan will talk about the actual INS parts here in a bit. And what we're proposing here is a one full turnkey solution that will allow folks to collect the actual data here wherever they actually are. Why? So we're trying to package a all-in-one solution here, as seamless and transparent as possible here. That the operator, customer, client, whoever it actually is, has a tool or has a means to really perform highly accurate surveys. More importantly, from an operational sort of perspective here, something that's low cost, low operational cost, low logistics true as well. Any environment that it may be as difficult to get any sort of, if you have a boat platform that you have to bring somewhere, and it's not possible just because of the sheer challenges of the area, this is one tool that could particularly be a tool that could assist you in the actual area here. Shallow areas. So if you're working in most of these areas here, a lot of these spaces aren't really deep. They're actually shallow. Again, tools like this can excel as well. And return on investment. We think that this all-in-one solution is also helpful toward that as well. And the last point here is lower replacement costs. I mean, of course, everyone knows accidents happen. Safety is the utmost important thing. But if something were to happen, we would probably argue that it's much cheaper to replace the actual boat than it is to replace, your more expensive equipment that you might have in there as well. So one should consider that too as well if they are going to be doing this work. Some of the features here, again, we, as well as Trimble, make marine grade stuff, right? So all the hardware has been tested. Our engineering teams will actually go out there and test. We certify the boat to IP67, which means that basically, if you have an IP67 rating on your hardware, it means that your thing, in this case, it would be the actual boat here, even though it's made to actually float on top, on top here, it can actually be submerged underwater down to 3 feet for a half hour, and it won't intake any water inside the hull, and potentially actually damaging any of the components inside. So some of you folks I know out there work in very harsh areas, and this is one of the reasons where we almost over engineer on purpose, because we know that you folks are really going to be working in these really harsh areas, and to be quite frank here, you're going to actually beat them up, right? And we understand all that. So we have extra pieces, extra hardware on there. So we have, for example, skid plates built kind of built on the boat. The sonar sensors are very protected. There is a acoustic sort of shroud that surrounds the actual sonar. So if the boat were to run aground, and it will, because again, people are operating very shallow areas, you can sort of have the confidence here that your sensors will be safe. The other philosophy here, again, for us, is the sensor payload that we employ inside of the actual boat. It could actually be swapped out, pulled out, and put into some other boat, right, as well. So if there is an application, and nothing of this boat is the perfect all-in-one boat for all areas, it's not. So it's not actually going to be able to handle if you're offshore in a sea state of some sort out there too as well. But you can have actually confidence knowing that, I can pull out the single beam sonar, right, and I can actually mount this hardware somewhere else, and you're still able to collect the actual same type of actual data that you're trying to collect. I think that's a very important one too as well. And the last 2 points there, really the engineering in terms of the hardware and how the boat is actually built. The thrusters, the propulsion, the steering, it's solid. This is sort of what we're actually known for here. Our competitors tend to use maybe some other less robust materials on their boats. We don't. So this is something that we don't actually skip on. So the thrusters are actually made, I'll phrase that. The propellers are made out of brass, either brass or steel. So they're built to withstand sort of any environment that they might be functioning in. The hull itself, and there's a other slide here in the pack here that terms of exemplifies some of the areas that these boats actually worked in. Some of these applications are actually very caustic. So either there's something like acid ponds or they're alkaline ponds. So the hull material is actually a high impact ABS, but it also has a special UV coating on it as well that sort of actually protects it. So that's sort of the other piece there in terms of the actual engineering of the actual platform. Quick note on Oceanscience. So Oceanscience was actually acquired by Teledyne about 8 years ago now. However, Oceanscience has about a 20+ year history. They were one of the front 4 runners in the actual unmanned industry. There are literally hundreds of these boats all over the world. Some of these boats out there now are actually, most of these boats out there now are still in use, and we love to hear that. So we have one customer here that I am aware of, and he's been operating a boat now for about 8+ years now, and that's great. Safety first. This is definitely one of the engineering ethos things again. So any sort of safety feature, safety redundancy, we add on the boat specifically because, again, we understand that these things are unmanned and that as you as the operator are going to want to have some sort of reassurance and confidence that your vehicle or your platform will sort of actually come back to you every time there. So with that, Jonathan, we're going to start talking about the actual internal hardware here. Would you like to actually kick us off here?
Sure thing. Thanks, V. So Trimble BX992 INS at a glance. It's a dual antenna for precise heading, multi-frequency with support for all GNSS constellations, L-band support for Fugro Marine Star or Trimble RTX, which is available now for marine applications. That's Trimble's own L-band service. V mentioned IP67 rating for the vessel, also the BX992 enclosure and the antennas that are part of the system are also IP67 rated. Of course, NEMA output, that's important for marine, pulse per second output, of course, different interfacing and to give you some options as far as communications, RS-232, USB, Ethernet. It's very lightweight, 0.75 kg, about 1.5 pounds roughly. It's small, fit in your hand. 20 hertz is the standard update rate, but 50 hertz is optional. But you can purchase an option code to enable 50 hertz output. 9 to 30 volts DC on the power side of things. Certainly RTK capable. And later in Q4, I don't have an exact date for you, but we are expecting to roll out a firmware upgrade option that will enables the INS. The sensors are already inside the enclosure. The firmware upgrade gives you INS capability, and you would need to purchase an INS option code to enable that feature. But once you do that, you also get GAMS calibration and heave filtering. So things that are very common for marine applications. A lot of you guys are probably accustomed to having some of those features already. So that is coming in Q4. I don't have an exact date for you, but we expect it by the end of the year. And I'll talk a little bit more later about some of those specific features in one of our upcoming slides. But I'll turn it back over to you, V.
Thanks, Jonathan. Yeah, some really exciting stuff here that's actually coming out here. So on the Odom Echotrac E20 here, I won't steal Odom's thunder since I'm talking about this the following week. I will, however, tell you that this is the sensor that's integrated inside the boat. It is a dual channel, dual frequency system. So by that I mean, if some of you familiar with for example, the Odom CV100s that we used to use on the actual boats here. What that means is basically, as opposed to having one dedicated, one high frequency and one low frequency channel, you have two separate channels that can actually operate as a high or low. So pretty cool stuff here. So Odom also creates their also sensor payload as IP67 as well. Again, you know, it's not that we try to over-engineer these things. We know our customers and we know what you folks actually do to these things. So we try to make these things match as much as we can in terms of the potential environments that you folks might be working in here. Some of the exciting advancements of the E20, again, I'll let Kim talk about this the following week here, is that some of the multi-beam advanced algorithms that sort of are in our sister actual product line with the Reason T series. I mean, some of this is actually filtered down to the E20. So if you think about it, you're buying a single beam sonar with some incorporated multi-beam advanced tech kind of inside as well. So some pretty cool stuff there. And with that, basically what this means is that for single beam customers, as you know, your bottom is what your bottom is the most important thing, right? So where is that seafloor? So if you're in the actual dredging industry, that's how you folks are actually paid, right? So how much dirt was actually moved, how much sand was actually put back in the actual area. If you don't have an accurate actual bottom lock, that's a pretty critical piece in this. And the bottom block algorithm on the E20, I would tell you, is as solid as I have ever seen. So we've had this thing in several different turbid areas, from clear to really turbid areas, really murky areas, and that actual once the E20 finds the actual bottom, it will not move. So what this means for the operators that you sort of get higher confidence, that you get some really clean data, and more importantly, highly accurate as well. So when you start doing those actual calculations for quantities, you can have confidence that that your first time you're out there trying to collect data is right. And again, if you're, I know that a lot of the operators here, or the folks on this call here, you might be using some other piece of software. It's the same ethos here too as well. So the E20 is compatible with a lot of the third-party software out there. This does also include the Trimble marine construction software. There's a single beam module on that one too as well. Jonathan, not to put you on the spot here, but maybe on the last slide, you can talk real quickly about the Trimble marine construction single beam platform.
Sure.
And we'll have a conversation there. Thank you. Autonomy. This has always been one of the questions that folks will actually ask as well. And what are you guys actually doing to as well? So right now, the current state of the boat right now, and I say this in its current state right here, I would term this in more of a autopilot. So operator draws some sort of survey grid. You say, here's my actual area, here's my line spacing, go. And basically the boat itself will actually drive this preset line very accurately as well here. But what I wanted to point out too as well is that we're starting to add other functionality again. So this is sort of the power again of Teledyne Marine and an integrated engineering team, because this picture of an AUV is not a mistake here. AUVs, autonomous underwater vehicles, and boats operate in a very similar way. So both go, either one goes underwater, one goes on top of the actual water. They sort of have the same sensor suites on them as well. But the AUV industry has sort of been far ahead, really, of the unmanned surface side of things in terms of advancements in autonomy, only because their environment is a lot harder than ours. So realistically, you drop something in the water and it goes underwater, you want to make sure that it actually comes back, right? So that technology, like mentioned earlier with the E20, is also happening on the unmanned service boat side as well. So really excited to share that this time next year, you'll see some very cool advancements for the boat, and and a lot of this work sort of is coming from the actual AUV world. So I look forward to sharing that as well. But you should know that there is an autopilot option on the boat currently. Transportability and portability. Our vehicle is very portable. Again, it's really engineered, really designed to work in these areas that are really hard to reach, right? So you reach some sites and it's basically, you don't have an actual ramp. Access to the water is tough as well. So the boats are really sort of built with a two-person operations sort of in mind. So basically, 2 people grab the boat, drop the boat in the actual water, and then 1 person to actually operate it, right? So 1 person to operate to either manually remote control the actual boat, or autonomously, or have it drive on a autopilot and just have some sort of preset area, and the boat will actually map the area for you while the operator is focused on the actual data collection. Again, we build these boats so that they get put into trucks and vans and sort of any sort of transport vehicle in lieu of having to bring their own boat. So some of the current ways that folks do these work now is that they have to bring in their own boat trailer, they have to worry about fuel. All of these things are actually become a non-issue if you have a Z-Boat platform that you can just kind of throw into the back of your truck, have just charge up the actual the actual power pack for all this, drop the boat in the water, and go. Just to reiterate this point again, these sensors on both the Z-Boat that's currently installed, again, they can be transferred over again. So we actually get, I personally get at this quite a bit. Can these things be actually pulled out and used elsewhere? The answer is yes. So if you have some application somewhere, again, you might be working in an area where the Z-Boat may not be the best tool. That's okay. You still have your ROI, knowing that I can pull up these sensors, find some other platform that might be best suited in this area, and use that as well. From a value perspective, again, one of the things that we want to actually point out here is that the 1800T, while it is configured for an E20 and some other things as well, the sensor wells are actually interchangeable here. So it's kind of hard to describe here, but we actually shun the moon pool design only because we found in the actual past that we've actually tried that in the actual past as well. And what we found that depending on how you mount your sensor, moon pools create cavitation. So they create a lot of air bubbles underwater, which will degrade the quality of your actual data. So we really tightly integrate, and we sort of have this, we engineer smooth, hydrodynamic, tightly integrated sensors, because we specifically focus on trying to minimize any turbulence that you might get underwater, because again, for these sonars to work effectively, they have to have clean water. And by clean water, I mean, you can't have trailing air bubbles underwater, and so on and so forth here. But just want to let folks know that you can, and if you want, swap out your sensor packages based on your application and need. Just some last slides here, just some use case examples here. Again, there's definitely an uptick here from the mining and tailing ponds kind of world. These are very caustic areas. Again, acid ponds. Boats, again, engineered in such a way that they're resistant to these sort of areas here. And this is, if some of the folks are familiar with it here, these are actually ash ponds. Ash ponds are also a residual byproduct of coal. So coal ash, so a lot of these actual power plants used to burn coal, right? So those ash ponds had to go somewhere. And unfortunately, a lot of these ash ponds, a lot of that ash went into ponds. So as you can imagine, these are, again, very harsh areas as well. And again, you, the customer, or you, the operator, or whoever it is, can have confidence that these are actually engineered to kind of handle these areas as well. really hard to reach areas, any sort of low overhang, very, what's the word I'm trying to get, but basically any sort of obstructed area where you might have to do a inspection of some sort over here. These boats excel as well. And, some of our customers here with these boats do some pretty cool things with the boats as well. And, again, it's all about keeping the folks safe and trying to keep your most important asset, which are your people, out of harm's way. And more importantly too, being any sort of, again, where these boats shine is any sort of area that you might not be able to get traditional boats in. So for example here, if any of you had been to the Pearl Harbor, the Pearl Harbor area there too as well. I mean, these boats are really a great tool for those kind of areas here. So I just want to point that out too as well. This is basically one of the extra closing slides here. So just to recap, I mean, I apologize for the small font here. This is just basically, you'll have access to this afterwards. This is being recorded if you need to kind of loop back here to sort of get an in-depth, detailed look in terms of what the actual platform has. Again, it's the actual boat itself. These are more of the actual engineering, actual details, the specs, if you will, in terms of the boat, the sensors included, how the boat, the propulsion system of the boat, and sort of any other power system as well. And again, everything that we sell is backed by a full 1 year option here. So, or 1 year. So if anything happens with the boat, well, if anything happens to the boat, that's our fault. I'll put it that way, because I've seen folks actually do some interesting things here. We will completely cover. And so, Jonathan, would you like to take a bit here to actually talk about the hardware?
Yes, of course. I'll talk about the Trimble side. So the GNSS that we're packaging together with this product offering is BX992 with INS. The receiver comes standard with GPS, GLONASS, and QZSS, but it supports all constellations. You could just purchase other constellations if you desired them. It comes with a 30 centimeter by 30 centimeter standard accuracy, but you can certainly purchase RTK precision upgrades. There are a couple of different levels of precision that are available as part of this package. I mentioned earlier it's 20 hertz standard, but 50 hertz is optional. If you needed that, you could purchase that as an upgrade as well. It comes with a multi-purpose cable that was on one of the previous slides that provides serial Ethernet, PPS. So it's a multi-purpose cable and comes standard with the system, so you wouldn't have to source that. It will come with the 2 GNSS antennas. We have a couple of different models that we offer, the GA810 or the GA830. The 830 is more ruggedized, marine grade, heavy duty. That's the preferred and the one that we would recommend. But if cost is an issue, we do offer the GA810 as an option. It comes with GNSS cables as well for your antennas. Standard warranties on hardware and firmware that would also extend to software. If you just ask for a standard quote on this package, it would include TMC single beam software module. If that's something, if you already had software and didn't need that, I think it's okay. I think you can speak with your sales staff there and sort out which of these you do or do not want or desire. The INS feature is already built into BX992, but it requires a firmware upgrade and the purchase of an option code to enable that feature. And of course, with that feature, if you'll recall from earlier in the webinar, I mentioned it also comes with GAMS calibration and heave. But that is, I guess, kind of the package details as far as what comes with it as standard. But as I said, you could speak to your sales staff and determine which of these pieces you do want and do not want. Is that a fair assessment there, V?
Yep, absolutely, Jonathan. Thank you.
Yes.
Great. So yeah, so just wanted to actually drive this point home here, but again, just wanted to say here that the boat itself is built around a lot of expertise here. So again, because we're a very tightly integrated team of engineers, we have the Z-Boat in particular has access to engineers from the ROV side of things, to the actual AUV side of things, as well as the actual glider side of things as well. So what you're seeing is a lot an aggregation of all of these expertise, applications, expertise, prior experience too as well, that's really being focused in and being sort of engineered into the actual boat here. So from a value proposition, I hope that folks understand that we're not only a one trick kind of boat here that only do boats here, but what you'll sort of see here is a lot of this hybrid engineering and a lot of our actual platforms really actually permeating throughout the actual through all of our actual products here. And I think that's really cool, and I think that's really exciting as well to also share. My last slide here is, again, I want to thank you everyone for your time. Again, I think it's for Teledyne and for Trimble, very exciting here. I wanted to point folks out here. So if they are interested, if they have specific sales questions, this is the contact info here. If you are already a customer, we know that some folks are here. This is how you reach Oceanscience support specifically. So if you need to reach someone over the phone or someone over email, someone's there. And just that folks are aware, we have service support areas in Europe and in the US here. The European Service Center also covers Asia as well. So if there's any questions on who do I call or who do I talk to, please let me know. You can contact sales and they'll have a way to actually reach out to me here too. But beyond that, again, thank you for your time. And Melissa, I'm going to throw it over back to you.
Great. So thank you, V and Jonathan. Great presentation. We have a bunch of questions, which I'll start reading off for you two as our panel experts, so you can answer their questions. Before I do that, I just want to mention again, V had mentioned the fact that, and I had mentioned earlier this morning when we started, the fact that we have a deep dive presentation next week with Kim Daly and Christian Shaw on the Teledyne Odom E20. So please go to our link channel if you're interested in that and register there. You can also, when you're registering, indicate that you want to be on our mailing list for future updates so you don't miss what's coming up on Link going forward. Also, we have recorded a number of podcasts at our Marine Tech Talk station with some survey boat owners and operators, which may be of interest to you. That's another place to check for resources. Okay, without further ado, I'm going to get started with the questions. The first one is, what wave height is the limit for Z-Boat for survey?
Okay. So thanks for that question. So the wave height limit, so the boat itself can withstand sea state 3 is what I say, which is actually pretty high. So about 1 to 2 meters of wave action, but it's just like any other survey actual platform as well, where I would say if you want survey quality actual data, you probably don't want to be operating more than about 1 meter to 1.5 meters maximum of wave height, depending on your sea state as well. So if it's swelly, so if it's just swells coming through, it's fine. But if you have actually waves that are actually coming over, yeah, you probably talking about 1 to 1.5
Great.
Could I add
Sorry.
would you mind, Melissa? I'm sorry if I'd like to add something to that as well, if you don't mind. With regard to C-State, I need to make a few points about BX992 as well, and as far as its capabilities. There may be C-State that Z-Boat can handle from the platform and design perspective, but there are also limitations to what BX992 INS can handle. It's not high end, okay? So that we at Trimble are not promoting BX992 INS for heavy sea state conditions. We are promoting this for primarily inland waterway, low dynamic types of environments. The BX992 INS is designed to be a cost-effective GNSS precise heading INS solution, but it will not perform at the level of an Applanix POS-MV. So if you are in a high dynamic environment or intend to be in a high dynamic environment, BX992 INS may not be sufficient for what you are attempting to do. Some of the specifications are included in that PDF, I think, that Melissa has attached as a handout to this. But we're more than happy to have a detailed conversation about what BX992 can and cannot do. But I just caution you, it's a low-cost integrated package designed for cost-conscious surveyors. It is not designed to perform at the level of a higher-end IMU like an Applanix POS-MV, and it will not perform at that level. So heavy sea state, BX992 is not going to perform well. Just be cautious, be advised. But rivers, inland waterways, low dynamic environments, shallow water surveys, I think BX992 can perform quite well in those types of scenarios. I just wanted to add that.
Thanks, Jonathan. Appreciate that. All right, so going on to the next question. We have a bunch here to get through, so let's see if we can get through as many as possible. We run out of time here. Where is the data logging, at the Z-Boat or at the operator's site?
So the Z-Boat, so both. So the E20 does have the option to actually log, but if you're using a third-party piece of software, then you would be logging at that site. So if you have your remote station set up on shore, that's where it would actually go.
Okay. Another question, do you intend to integrate deep learning in the future versions of the Z-Boat 1800T, for example, for classifying objects in the ocean bed or dehazing the underwater images?
Yeah, that's a very cool question. Yeah, so the AI piece to this, I will tell you, is part of the pipeline here. As some of you are aware, there are some sister companies to Teledyne that do this sort of work as well. So I will tell you that it is part of the roadmap. I just don't have an actual timeline.
Okay. Regarding the simultaneous use of LiDAR and the Odom Echotrac E20, does the processing software allow you to get an integrated and corrected bathymetric coastal topography representation?
Yes. So basically, well, I'll say yes with an asterisk on that. It'll depend on your acquisition software. If your acquisition software is configured to acquire both actual data streams, so coming from the actual LiDAR plus the BADI as well from the sonar, you're sort of co-registering, or you're actually geo-referencing both actual data sets at the same time. So what you'll see on your screen is basically a real-time topo, real-time topo BADI map, but that's again depending on your software.
Okay. Next question: is there any obstacle avoidance sonar on the boat, and at what range does it work if there is one?
Yeah, also a good question as well. that is also on the product development roadmap as well. I alluded to this in one of my earlier slides with the AUV in there. If you look at our sister company, Gavia, and some of the work that they've done, that sort of smarts, if you will be also included in the boats as well. So not trying to punt here, but I will say there'll be something in there. I just don't have a clear, firm word yet on what that will actually be.
Okay. What is the maximum distance range that the Z-Boat 1800 can reach while maintaining robust wireless communication with the operator?
Mm-hmm. That's actually a great point as well. So that can go a few ways here. So again, the AUV community, sort of the way they operate is that they operate in a intermittent kind of world, right? So they expect to preset the AUV, drop a thing in the water, autonomously go collect actual data out of comms range. So the operators may not even know, well, it may not have a real-time update, but the robots operating underwater and trying to collect everything all at the same time here. But if you need real-time comms, the maximum range, depending on how high your shoreside antenna is, you'll get about, I'd say comfortably 800 to 1 kilometer range if you need real-time comm.
Great. Next question, what's the use of INS and double GNSS antenna with single beam echo sounder?
So, yeah, I'm sorry.
What is it?
Yeah.
The question reads, what's the use of INS and double GNSS antennas with single beam echo sounder? I'm not quite sure what the intent is.
Jonathan, to me, it sounds they're asking, why do we have 2 antennas and an IMU? So I'll let you take that piece and what that INS system actually gives you.
The BX992 dual antenna is designed to give you a precise heading, and I believe the specification is like 0.08 degrees of heading. You could use a single antenna, smart antenna. We've even tested with this system the Trimble SPS 986, which is a possibility. You could use a single smart antenna for some single beam applications. But we've put together this package because it gives you some versatility. If you wanted that precise heading with dual antenna, which sometimes you're going to want it, BX992 can give you that. With regard to the INS again, it gives you more options. If you don't need it, don't buy the option code, don't enable it. But the feature is there, and if you needed that attitude compensation per your use case and what you're trying to accomplish, then it's built in to the system. So the BX992 with the INS is designed to give you options for dual antenna. If you need that precise heading, you can achieve it. If you need the INS motion compensation, you can achieve it. Not across the board in all conditions, as I indicated before. A heavy sea state, big swells, offshore, things like that. No, a BX992 could not handle that. But if you needed that the INS component, it's available.
Okay. So I am going to acknowledge the fact that we are actually over time at this point, but if the audience is interested in hanging on and hearing the last few of these questions answered, I think our team can stay on. Just give me a nod, guys, if you're still available to hang on for a couple more minutes and finish answering some of these questions.
Sure.
And I appreciate everybody's time and patience as we run through these. The next one I have is the survey instrumentation powered from the Z-Boat batteries, and therefore how long could the batteries last doing a multi-beam survey?
So if it's a single beam survey on the E20, just want to make sure that we're actually clear here. So I'll tackle that one first. On the E20 single beam survey, the boat's wiring system is wired such that you can wire everything to run off the same, so everything, basically run all batteries in series, where your entire battery bank runs everything. So your propulsion, steering, so on and so forth. We also do, so the boat is also wired such that it's flexible, so you can actually branch off and split the batteries for the propulsion, keep those separate from the actual sensors. So if the sensor payload is powered off of its own batteries, basically, you can run that for I've run for long as 6 to 8 hours. The boat itself, though, however, depending on your speed and depending on where you're working and you're operating, if you're operating about 3 knots on a single beam system, you'll get about 4 to 4.5 hours out of the boat. On multi-beam systems, it just depends on how it's cooked up. So the boat power systems, they can be flexibly set up so that you have to put at least 3 packs of battery in there. But if you need to actually front load and actually add some more, you can add up to 6. So single beam systems, you need about 3 packs. Multi-beam systems, you need about at least 6.
Okay. Our next question first starts with a thank you, guys, for your time, and they appreciate the webinar information. The question that they have is, can the RTK solution be via connecting both of the BX992 antennas to a local R12I as a base or other antenna as a base?
I don't know why you couldn't use any base that you wanted. The BX992, there's nothing preventing it from utilizing various sources of RTK corrections. It's capable. You can connect a UHF radio to speak to a base station. You can integrate cellular technology to use a virtual corrections network. You can use L-band, IBSS, so an internet base station. You have some options there. I don't know what would prevent you from using it just like you would any other Trimble GNSS. Does that answer the question, or is there more to that?
I think so. If not, hopefully they'll submit another question for clarification, but hopefully. I have another question, I think, for you, Jonathan. Why are there 2 receivers? Why are there 2 Trimble receivers on the Z-Boat?
There is only 1 Trimble receiver on the Z-Boat. There are 2 antennas because it's not a smart antenna. It's not an integrated GNSS antenna and receiver combo. So like the SPS 986 or the 985 prior to that, 585. These had integrated GNSS antennas with the receiver itself. BX992 is not like that. It works more like our modular receivers, where you use TNC connectors and antenna cables to connect to the antennas themselves. So what you saw mounted in the images in this webinar were just antennas, and they were connected via cable to the receiver.
Yeah, and I'll also add too as well, real quick, but it's the heading portion of it. So that's why there's the 2. Excuse me. Some applications require really accurate heading, so that's why you need the dual antenna on the actual boat, because then they have a way to sort of gauge your heading much more accurately than you would with just one head. So that's why. So hopefully that clears it, but if not, they can always ask a follow-up question.
Sure.
Okay. Next question, during emergency stop or low battery, will the USB return back to the launch point? What will be the standard operating range between the remote control, remote access, and the vessel?
So stay tuned for that one. That is one of the features that we get asked about quite a bit too as well. So the safety features right now, if you have a low voltage alarm, there's a lot of things that actually pop up. So you'll get a audible alarm from the RC transmitter. You'll get on your screen, there's a on-screen indicator as well. So there's several indicators on the actual boat itself that you'll get low voltage on there. In the future, we are making this smarter in terms of, okay, well, if the boat does detect a low voltage kind of scenario, do something smarter. But I'll leave that at that until that actually comes out next year.
Okay. Is there an RTH option available in the control software in the time of lost communication or low battery?
Yeah, that's very similar to what the earlier question was here. But yeah, there is some autonomous smarts kind of built in. Right now, it's very manual that the operator operating the actual platform has to be really in tune with what's happening right there. So we sort of say the operator's in the loop, right? So the operator that's actually doing the controlling of the platform has to be really in tune with what's happening with the boat. So what its actual voltage is and so on and so forth. So they have to be really attuned of what's happening, but in the future, we're going to make that a bit easier where it becomes more operator assisted as opposed to operator in the loop.
Okay. We have two last questions. What about FPV? Is it installed?
I'm sorry, can you repeat?
It says, what about FPV? Is it installed? I don't know what FPV is. It's not defined.
Oh, that's first person view. Yeah, so there is an IP67 camera that's installed on the boat itself. So thank you for pointing out. There's an HD 1080 I camera that's on top of the actual rail there, and basically via an IP address, the user can actually log in through your actual Chrome browser, Firefox, Edge, what have you, and the operator on shore has a real-time video feed of what's happening on the boat. So yes.
Okay. And our final question is, can we work with more than one vehicle and have the data merged? Can we command and control multiple boats at the same time?
Great question too as well. Yeah, that's the other bit that's not trying to give too much away here. Stay tuned. But yes, that is the capability to sort of work as a conglomerate of vehicles is one of the things that we're trying to work towards, right? So as an integrated test platform, an integrated platform between all of our our boats, our ROVs and AUVs, so on and so forth. That is sort of the roadmap that we're trying to work down towards. But I'll say soon. How's that?
Good answer. All right. So first of all, I thank both of you for your expertise today, V and Jonathan, and all the great information that you provided. And especially thanks to all of our audience today who have really hung in there till the bitter end, 15 minutes late to hear the question answered today. So thank you very much, everyone, for your attendance. And we hope to see you at another Link webinar soon. Have a great day, everyone.
Thank you.
Thank you, everyone.
Stay safe.
Stay safe.